So in class we talked about functions, and we also talked about how we pass in parameters, pass in variables as parameters into functions. So today I'm going to go over two common ways that we covered in lecture about how to pass variables into functions. So let's take a look at this simple program that I wrote over here. What we're doing in our main function over here is first we define a variable, integer type variable called num, and we set the value to 10. And what we do over here is we pass this num variable into this function called add num, and then when the function finishes, come back to main, we just print out the value of num. Okay. What we're doing over here in add num is we're taking an integer type variable called num. We're calling it num over here, and then after auto operations inside the function, we return nothing because return type is void. Okay. So one of the most crucial things that you have to really make sure today is, although we have a variable called num over here, we also have another variable called num over here, and in fact we're passing num over here in this function called add num as a parameter. They have the same name, but they do not refer to the same object. I have to emphasize it again. They have the same name, but they do not refer to the same object. What's happening here is when I define this integer type num over here in this main function block, I'm creating space for this local variable called num, and I set it to 10. Should be fairly straightforward, okay? And when I call add num, the program allocates another space for this add num function block, and then over here it creates its own local variable, also called num. And what's the value to it? Because we're passing 10, we pass it over, so this num is also being defined with value 10. Okay, following? So in this case, we can see in the memory we have two different chunks of memory that is called num and has a value 10, but one belongs to the main function block and one belongs to the add num function block. They are two different objects. So when we're working with all the nums over here, we're working with the num that's being allocated over here in the add num, and all the num operations down here in the main function block is the local variable that's being defined in the main function block over here. Okay, so they're two different objects. Therefore, if I add 10 to the num over here, I'm adding 10 to the local variable num that's being defined in the add num function block, and I print it. So what should the value over here be? I would be getting 20. Okay? And then I finish my function, get back to main, and I print out num again. What is this num? This num refers to the object that's being defined over here, which is a local variable num that's being defined in the main function block over here. So what do I get? I get 10. Okay? Make sense? So because we're working with two different objects, okay, when we modify things over here, we're not modifying this object over here, we're modifying this one. So these two variables are being manipulated separately. This is called pass by value because all we're doing over here is we're passing the value of the variable num, and we're not passing a whole object. It's creating another object here in add num function block. So you might be asking, how do I actually change the value down here in this num? It's fairly simple. It's called pass by reference. Okay, pass by reference. The syntax is also fairly simple. All you need to do is add an ampersand sign in front of the variable name up here in the function. So in this case, instead of passing in just a value, we're actually passing in a whole object, a whole reference to the same object that's being found up here. Okay. So the ampersand in early lectures, you know that it's called the reference operator. It basically creates another name that refers to the same object. Okay. So over here, what I'm doing is I'm creating another reference in add num, and instead of creating a new object, it's just a reference to this object down here. Okay. So of course, we first make it 10, and then we pass it into this add num function, and this num is just a reference to this object over here. So when we add 10, instead of we're manipulating a local variable that's being defined in add num function block, we're actually doing operations on this object over here. So when we add 10, this object over here changes its value to 20. So, and we print num over here, we get 20 as expected. And we end this function, we get back to num. And when we print this num, what would the value be? Which object is it referring to? It's referring to the object over here. And what's the value? it's 20. So this kind of difference is that we're passing a reference to the same object. So when we're doing all the operations, we're actually manipulating the same exact object over here. Okay, so the value gets changed over here. Everything that's being done on this variable object applies when we get back to this function block over here. So you might be asking about like when do we want to use passing by reference or when do we want to use pass by value. So pass by value is helpful. One case that I find really helpful is doing recursions, or like just when you want to pass like when you want to maintain a clean object when we go through different layers of function calls. Because sometimes you just don't want to interchangeably change the same or accidentally change the value of one certain function block. And pass by value can ensure that your data value doesn't get modified accidentally in another function block and mess up the whole program. But sometimes you do want to use pass by reference, and one of the most common applications of pass by reference is like when we want to save more memory or save time. Because if we do pass by value for, imagine we're not passing just a small integer, we're passing a huge data structure, maybe like a huge vector, which we will probably learn in X280 or in future courses. We want to pass in a huge data structure. And if we do pass by value, what happens is we create a whole clone over here of that huge data structure. And copying stuff takes time, it's expensive, and it also costs memory. So sometimes if we're like okay with like modifying some things, we can just pass by reference over here. And instead of like copying all the stuff up here, we can save memory and save time by referring to the same object. And you can learn more about that in X280 about how to not accidentally modify the values, but that's like for further future topics. So these, of course, is just a very brief introduction to what's going on through this passing by reference and passing by value question. And you'll learn more about it in X280 when we talk about stack frames.